other aspect, but a mechanism for bacteria to make ATP by being stimulated by light. Right? Carbon fixation, production of carbohydrates came later with the addition of photosystem II. So you can add on to that. Photosystem II, there's no point. You can't, there's no cyclic aspect to photosystem II. So photosystem II is no good without photosystem I. Photosystem I is fine all by itself. So you always study them in reverse order, but they probably evolved in the order of their numbering. But they were numbered because of the sequence of their discovery. So it's all confusing as far as why they were numbered the way they are. Yeah?
Are both electrons being transferred by the PC?
No, PC one at a time. Just like what other electron carrier?
C1.
Not C1.
C.
PC. Yeah,
I have a question. Can you explain why?
probably not.
Can you explain why NADPH is worth more ATPs than FADH2? Is it because FADH2 is on the?
It's not.
I mean, worth less. Or no?
NADH and NADPH are both worth
Oh no,
3
I meant
ATPs.
the difference between that and
FAD.
Yeah.
FADH2 drops off electrons farther down the electron transport chain, so where the electron transport chain will pump out somewhere between 6 and 8 protons. The electron transport chain from FADH2 down, succinate dehydrogenase down, pumps out 4 to 6. So it's about a 2 to 3 ratio.
Because it's down the electron transport chain.
Yeah, it starts, it either starts up here and gets all of the pump, or it starts here and only gets a portion of the pump. Yeah,
I can't read what you said right in front of pyruvate on page 3.
page 3, fates of pyruvate.
Fates of pyruvate?
Fates. What happens to pyruvate? Goes to lactate, goes to ethanol, goes to the mitochondria.
Okay, thanks.
When you say C4, do you mean like the anatomy of a leaf or the C4 pathway?
Everything.
Okay.
You did Atroplex in lab. So if you did a good cross-section of that, but I also did a generalized C4. Kranz anatomy, good term to know, because it's German. And it means wreath. So you'd be in the holiday spirit, you can put a Kranz on your door.
Then it's called Adventskranz.
What?
Then it's called Adventskranz.
A what Kranz?
Adventskranz?
Fence?
Advent, like Advent.
Oh. Three semesters in German.
Well,
Could
you
you,
said it really good.
Could you draw a carbon fixation?
Can I draw carbon fixation?
Or can you do
Yes.
it on the board?
So basically you've got a 5-carbon sugar. It is a 1,5 bisphosphate. It is a keto sugar. And it is a death sugar. That is D for death. And fill in the rest of the molecule. And ribulose 1,5-bisphosphate carboxylase oxygenase is going to do is it's going to add carbon dioxide. And carbon dioxide is going to be added such that you get 3 PGAs. So you're going to get a PGA here. This is 3-phosphodiacetic acid. And I'm going to get so the carbon dioxide is going to become part of this molecule here. Sort of doesn't make any difference which one. And it's really going to be CO2 plus H2O is going to give you HCO3 minus plus a proton. And that accounts for the conversion of a double bonded oxygen to an hydroxyl group. And addition of a hydrogen nothing, going to COO minus with a plus.
Could you also write that as OH, or is that wrong?
What?
Could you write that as OH, the CO minus plus? I mean,
Yeah, you can, but it would be under extremely acidic conditions.
Okay, but it wouldn't be wrong on a test.
It wouldn't be wrong.
Okay.
Unless I specified the pH. The, let's see. When we went through photophosphorylation, we talked about P680 and P700. And resonance induction. Electron excitation. Electrons boosted